Well, today was a really exciting day. I want to thank all the panelists for being here and the individuals that came from far to present from Nature Fresh Farms, VMware, GCP, Kamiwaza. Um, I hope that the key takeaway for me was that we do see many AI deployments. And when we specifically talk about deployments, I'm talking about inferencing on CPUs. And there are many reasons why we see customers make that choice. Nature Fresh Farms was a great example of the real world, day-to-day challenges that customers face. And when you look at those day-to-day challenges, making choices on how to deploy, meeting critical requirements. For them, they had a critical requirement of less than 30 minutes, and the CPUs were able to meet it. And so for them, it just didn't make sense to consider going to anything else. And so we met their critical TCO requirements on the CPUs, and they didn't see a need to have to transition, which is one of the key areas where we see customers consistently again and again choose to use us. And it also comes down to the ease of deployment. There are definitely some infrastructure challenges that happen when you start adding new products to your systems, and for them, by sticking with CPUs, they didn't have to worry about that. They were used to using it, they know how to manage it, and they were just able to add the AI workloads to their application. VMware, I think the exciting thing about VMware was the statement, which makes me laugh, but use CPUs when you can and GPUs when you must. And the demos that they showed about being able to inference 7 billion parameter models, and they were doing 3 simultaneous inferences on a single system. They were able to do the image tracking algorithm on 8 cores. So once again, demonstrating that as you start looking at some of these smaller inferencing use cases, you can use CPUs. And in fact, you should use CPUs when you can. But there are times when you're going to have to go to a GPU, and it makes sense to understand where that threshold is. It's going to vary from customer to customer. With GCP, I think the interesting thing that we saw is, the key statement is a majority of inference is done on CPU instances today. And that was more in terms of the context of the number of broader enterprise customers. And this goes back to a statement I made in the presentation earlier, which is when you have this massive scale training or inferencing scenario, you should go to an accelerator. And I don't know if you remember, but Brandon basically said, hey, these massive scale scenarios, which require significant amount of systems, those are going to GPUs and TPUs. But a majority of enterprise customers who are deploying more real-time, smaller models, more nimbler language models, we're seeing that they're choosing to deploy on CPUs. And that really resonated in terms of the context of everything that was talked about today. And then finally, Kamiwaza, the key thing is when you look at starting to build these systems and deploy AI systems, it is a massive challenge. That entire pipeline is not easy to traverse, and it takes quite a bit of expertise. And so identifying ways to simplify that journey, VMware, Google Cloud, we're doing quite a bit of that. And it takes key partners like Kamiwaza to pull it all together, to simplify it for customers. And we have many partners like that that really just simplify the journey for you. And it was really amazing to see that they were able to get, the 5th Gen Xeon working so quickly. It just became available in Azure as a private instance, I believe, and they were able to get access to it and get it running and get really good performance. So once again, that ease of deployment, customers know how to use CPUs, are able to quickly deploy on CPUs. That really shines through in the example that they did. So it's really, hopefully, one of the key takeaways for me is that, if we go back to this journey, a lot of the context was around when you're doing model training, especially deep learning model training, you really do threshold to needing accelerators. And when you do start looking at deploying, there is a place for CPUs, especially when you're inferencing your solution on models that are sub 20 billion parameters. And really, once again, hopefully you heard it from most of our partners and a customer as well, that the reason why they choose to use us is we meet the customer's requirements, we enable ease of deployment, and we deliver TCO benefits for those mixed general purpose and AI workloads. So that's all I had. I wanted to thank you all for your time. Once again, thank you for the individuals that showed up to present today. It really was meaningful in terms of being able to convey where we see CPUs being relevant in the world of AI.
Go ahead.
So I really appreciated being able to hear from both partners and customers and all you all, and in a way that, you know, not everyone was just reading the same slides. They had their own perspectives, they had their own interests and everything, and I thought that was very effective. Um, I really liked the fact that there was a mix of demos and slides and just a talk, which turned out to be quite interesting. So I know you probably weren't looking for that kind of question,
Mhm.
but I just wanted to encourage that type of getting the word out and educating the public and IT in this unique way of doing it.
Yeah, I appreciate that. Thank you for that comment.
Yeah, I'd like to add on to it too, because I think the way AI has changed is it's just we're so early days of the digital transformation that it's obvious that it's here. There's so much hype right now that it's impossible to just be like, okay, like, how does it actually work? So, like, I really appreciate hearing more about the Xeon um, chips and where where they make sense to start using them for LLMs, and it kind of fits in with the whole private data center from VMware. So it ties back to a lot of the infrastructure stuff we're used to.
Mhm.
So I think we need a lot more of that, so people start getting the vocabulary to ask the right questions about actually doing this, and people just stop playing around with GPT. Do some real stuff.
I had to do a lot of lookups to understand what was being said because I'm new to this too, right?
Yeah.
Yeah, absolutely. It's a fast changing landscape, and with this fast changing landscape, I mean, a few months ago we were talking about large language models. Then all of a sudden we started talking about foundational models, which you fine tune. Then all of a sudden we started talking about retrieval augmented generation, and that's all within a matter of months. And each of those has a different way of being able to build and deploy your solution. So you're absolutely right. It is a completely changing landscape. People need to adapt and then learn the language and hopefully be able to understand, which are the right products for the right situations.
So maybe a question. I think, well, I don't know if it's even half of us are infrastructure folks here at the table, but I know for a long time, and I'm a product marketer. I have a product marketing agency. Been a product marketer for a very long time. And for a long time, it was a big struggle with really working with teams and saying, "Are you sure the developer is who you're going after?" And so it's obvious now, platform teams and that kind of concept, which is a new word for an old concept, but it is kind of making that calm down with it just being about developers. But I feel like, a lot of what you presented especially is for the infrastructure folks and helping us understand like why it's important to what we're actually building for now is coming more clear into focus. So, I mean, are you seeing the same thing, like who your audiences are and who are your audiences that you guys are talking to now?
That's a great question. I mean, the audience is highly varied, and the decision makers are highly varied from company to company. You have the CEO, the CTO, the data scientist, as well as the IT infrastructure teams. And when you look at those four major vectors, there are different reasons why each of them is making a choice or pushing for a choice. For IT infrastructure, there's the challenge of, if you think about just maintaining an infrastructure, it's a challenge in itself. Adding more complexity, creates more risk, more challenges for being able to scale up and be able to maintain something so complex. And so, absolutely, there's a message to them. There's messages to the data scientists, um, and even the applications engineers. The example that I provided with the video conferencing customer, they have their application that they're deploying. So they have an entire application team that is deploying the solution independent of AI. Now there's this team coming in and saying, infuse AI into it. And it's now two teams with the IT infrastructure coming together and saying, oh, we're on the same journey. Let's figure this out. So absolutely, we have to message to all of them and work with all of them to be able to successfully get those AI applications deployed at scale.
I was really hoping you had a less messy answer, but okay.
It's not.
It's going to be messy for a while.
Yeah.
There's a messy market.
Mhm.
Yeah, I do have two comments. One is when people look at Intel and they look at hardware, I think it's also important to see that the software behind Intel is very important. I mean, the hardware can be great, but if you don't have the software and the software tools to get the most out of the hardware, then the hardware is pretty useless. Then the second comment is that in AI, a lot of people talk about CPUs and accelerators. The CPU is also an accelerator, right? I think from a terminology perspective, it is important for people to realize that the CPU is a valid option and
Yeah.
should be called an accelerator when people use the word accelerator in their terminology.
Yeah, no, that's a great point. I think sometimes it's easy to take CPUs for granted because it does so much in your infrastructure. You don't think of it in a unique way as a potentially an accelerator. So I really like that sentiment.
Well, especially with the latest generation Xeons, it occurs to me that Intel is adding a lot of AI-specific accelerator functions directly to the CPU. And one of the reasons the 5th generation is so much faster at AI applications than the 4th, and the 4th was faster than the 3rd, is because of the fact that there are specific accelerator functions that are being added to the CPU, right?
Yeah, absolutely. I mean, with each generation, we are looking at continuing to push the bounds and make sure that we're delivering new capabilities. And you're absolutely right. From 3rd to 4th to 5th, we did make quite a bit of advance.
Yeah, I think that's one of the challenges too with calling out something like AMX. Customers don't care; they just want faster, and they just not want faster. The expectation is to be wowed.
Yeah.
When they say, "Oh, I'm going to do the lift," no matter how light or heavy it is, to go from one generation of CPU. I've managed environments that, as of 2020, still bought net new Itanium, not because it was better performant, but because making the argument internally to go from one platform to another is difficult. So when you do make that trade-off of going to a newer platform, you expect like business class changing. And I think from a practical perspective, in the Kamiwaza example, VMware talked about it. Nature Fresh talked about, just when they have lower business priority, they move it to the older Xeon platform. When they have more performant requirements, they move it to the newer cluster. They don't talk about any of the features. They just say, I move it to the newer platform when I need better performance. So it's both kind of it's built in that if I go to the next level of processor, that I'm going to get this performance. But to Frederick's point, we need to start thinking about these as accelerators. What feature of the platform am I getting that, as I break out my architecture and I say I need an accelerator, is this going to be an on CPU accelerator, or is this going to be an external accelerator?
Yeah. No, that's great.
Ro, I think there's a really compelling story in the go-to-market speeds and being able to adopt CPUs first. And Kevin's story from Nature Fresh Farms was really sort of inspirational there.
Yeah.
And I think one of the things, and we talked about this a little last night, one of the things that I would like to see, or maybe this gets into your sort of who's your market point that you're making, Gina, is a little bit more for the developer experience side. So from my perspective, just sort of as an application integrator, I'm familiar with products like, say, Llama Index and running models locally, and that I can do that on, Apple Silicon to Intel chips. I don't know how Keith found his path forward with CPUs. So I think maybe there's an opportunity or maybe some things I can learn from y'all on, like the software. How do I get started with this tool chain and grab that opportunity to beat my competitors to market?
I think that the VMware guys gave a really good presentation, like a part about that, because if you've just bought a server and it has the Xeon chip in it, it's the new chip, you have the capability there. You just need to make sure that all of your other hardware is at the right level, right, or the right firmware, software level, OS level, and then there's developer tools for the Intel side that you've got to get, and then you're good to go. Is that right?
Yeah, I mean, generally speaking, independent of AI, to your point, CPUs have historically worked across many different deployments. And generally speaking, most IT infrastructure teams know how to deploy CPUs at scale. When you start adding the AI side of it, I agree with you, things get more complex. And, you have different frameworks you could deploy in. We talked about PyTorch and TensorFlow, but to your point, if you're implementing a RAG-based flow, where you have like Llama Index or Haystack, does it just work out of the box? And generally, what I would say is yes, it works out of the box with CPUs, but we're constantly doing work to get things upstreamed into a lot of these different framework options, so you can get the best performance. And sometimes that takes time, and in order for us to be able to deliver that best performance early on, we develop our own extensions. But generally speaking, I agree with you. There's definitely a lot more education we could be doing to demonstrate how easy it is to do with CPUs. And sometimes it does take someone like a Kamiwaza to come in and say, hey, this RAG journey is not as straightforward as you think. There's a lot of complexity associated with it. Let us help you simplify it. And that's independent of whether you use, CPU or GPU or any other type of accelerator. You need another tool that helps solve the problem, which is why a lot of these tools come into existence or frameworks come into existence. Is there's this massive gap and simplification that needs to happen. The nice thing about Intel, to Frederick's point earlier, is that we have thousands of software engineers working constantly to make sure we work in all of these different, use case scenarios. And if you're using a virtualized environment with, in fact, there's virtualized environment with containers in them with AI, as VMware presented, CPUs will work in that environment. And so those are the types of things that we constantly are working to make sure just work out of the box.
Building upon a little bit of the last couple of minutes, one thing that was kind of unclear, clear, that it was unclear that we didn't have any performance data on it. Like lots of questions came up in different ways about how many CPUs would I need, or is a GPU appropriate? And I think there's a big gap at the moment of benchmarking against various different types of CPUs and models to actually highlight how much performance you can leverage out of a CPU. It'd be a great kind of paper, article, series of articles, a thing that was constantly maintained so that you could actually showcase exactly how fast these can inference, so that someone go, well, you know what, that meets my needs. I don't even need to look at GPU, because I kind of feel we're in the reverse market at the moment, where the GPU is almost the de facto thing of choice. If I want to do this, I need a GPU. Whereas if you had that data to back things up, maybe they wouldn't start there, and you'd end up with more like a nature fresh farms, where they've just kind of fallen into it because that's the resource they had.
Mm-hmm.
It'd be really cool if they all came out before a conference that's going to be in a couple of weeks.
It'd be really cool if there was a third-party independent company or a group that was doing some kind of, I don't know, you could call it like an ML perf even, benchmark that, Intel would participate in, right?
Yeah, so we do participate in ML perf.
There we go. Throwing you a softball there.
Yeah, I appreciate that.
Yeah.
No, we do participate in ML perf and other standard benchmark consortiums to make sure that you can see what the performance is side by side, and you could see what CPUs can deliver from a performance perspective. Generally speaking, what we do see, especially when it comes to inference deployments, is when you look at CPUs, it's not like we want to go in and say, you need to use X CPU to be able to deploy your AI solution. Most IT infrastructure teams have a CPU that they've selected, and they just want to add those same SKUs. Otherwise, if you have multi-SKU, it gets really complex from a IT infrastructure management perspective. So by adding the AI capabilities to the CPU, what we saw is that we could go in and say, well, what's your use case? What's your workload? What infrastructure do you plan to use for your general purpose workload? And know that you'll get really good AI performance with the AMX engine. And you could use the standard tools, and you don't have to change your infrastructure too much. or you don't have to change your infrastructure at all. You just add more nodes. And so that's, one of the key things for us is we do have performance data publicly, whether through MLPerf, and in fact on our webpage, we do have a performance webpage which we can share with you that shows benchmarks of all types of models and what type of performance we can achieve, whether it's sequences per second, sentences per second, or images per second.
And they are, I have to say, they really are trying to be realistic and have real world benchmarks,
Yeah.
and to open that up to not just cutting edge GPUs and clusters, and really try to run things. I mean, they have a mobile set, everything. We're actually going to have David Cantor joining us here at Tech Field Day tomorrow.
Oh, nice.
And he's going to talk a little bit about ML Commons and MLPerf. So it's fun what they're trying to do. But I think there is a lot of understanding in the industry that the specifics of your model and your software stack are going to change everything when it comes to performance, all the different characteristics of performance. Really, the only way to know is to experiment with different hardware and software combinations and see what works for you.
Yeah.
And I love what you said with the VMware quote. Basically, you shouldn't start with you shouldn't start with a chainsaw, right? If what you're trying to do is cut the grass, you should start with something that works and work up as needed.
Yeah.